Okay, I'm on page 12 of your packet. You guys know what a sequence is and what series is, and we're going to be going over what it means to be geometric. So this is a type of sequence. We learned a couple days ago that an arithmetic sequence meant we're adding or subtracting by the same amount each time. That's the pattern, and whatever we're adding by is called the common difference. And for geometric sequences, we're going to be multiplying by a fixed amount or dividing. And that whatever we're multiplying by is called the common ratio R. So I want you guys to go back to when we're trying to figure out what a function is. When we had our y values, whenever our y values were multiplying down the line, then we knew that it was an exponential function. So look at my geometric sequence here. It takes an exponential function, whereas our arithmetic sequence, where we were adding or subtracting by the same amount by the pattern, it was a linear function. So this goes hand in hand from what we learned a couple units ago. So notice the non-linear nature of the scatter plot. So it's actually an exponential, whereas our other one was a linear. Okay, let's look at a few examples. So in this geometric sequence, if I'm trying to find the common ratio, I notice the pattern, I'm multiplying by 2. So since we're multiplying by 2, I know it's geometric instead of arithmetic, or exponential instead of linear. So it's just calling it something different when we're talking about sequences, okay? So that means I'm multiplying by 2. Looking at this example, I'm multiplying by a negative 2. Negative 11 times a negative 2 gives me 22. 22 multiplying by a negative 2 gives me negative 44. Negative 44 multiplying by negative 2 gives me positive 88. So in this one, I'm multiplying by a negative 2. And my third example here, I'm multiplying by 2/3. Multiplying by 2/3. Multiplying by 2/3. Multiplying by 2/3. Alright, so that's how we figure out our common ratio. Let's flip the page over. So we have two equations for geometric sequences and series, just like we had two equations for arithmetic. So this is when we're talking about the sum, and this equation we use for everything except the sum. So whenever the question is talking about the sum, use this equation. When it's talking about anything else, use this one, okay? And I will be giving you guys these formulas on the test. Okay, numero uno. Find the common ratio for the sequence. So common ratio, I know I'm multiplying by a certain amount. So if I go from 6 to negative 3, I know that 3 is half of 6, so that means I must be multiplying by 1/2. But this is a negative 3, so that means I must be multiplying by a negative 1/2. And just to check, negative 3 times a negative 1/2, well, let me see, that would be negative 3 over 1 times a negative 1/2. Multiply across, negative 1 times a negative 3 is a positive 3 over 2. Okay, so I'm good there. So that means my common ratio that we say is R is equal to negative 1/2. Find the common ratio of the sequence given by this formula. Okay, well here I have a formula. Let's go back to this one. So I'm comparing this. Common ratio is equal to R. So I want to find out where in this equation R is equal to. Well, here I have A1, that's my initial value, right? R is our growth factor, so what we're multiplying by each time. So that means R is directly below my exponent. So the number directly below my exponent is 3. And that makes sense. I'm multiplying 3 times 3 times 3 times 3. My initial value is 5. So everything should kind of be clicking at this point because this is very similar to our exponential unit.